Hello everyone, I guess we'll get started. It is 3:30. My name is Ryan. I am from Security Scorecard. I am the Chief Threat Intelligence Officer, and today we're going to talk about supply chain detection and response, defending against evolving nation-state threats. So first of all, we're going to talk about the Indo-Pacific threat landscape. Kind of gives a color to what we're talking about here, from looking at the supply chain, looking at third parties, and what that landscape looks like. So the Indo-Pacific or Indo-Pac region faces a increasingly dynamic and complex threat landscape. So this is a geographical chart here of everything that can be seen from an internet-facing aspect. So these are devices ranging from web servers to IoT devices to SCADA devices that are visible to the internet, meaning that adversaries are going to leverage third-party suppliers. So it's not going to be coming through your front door. It's not going to be coming through what you would expect as being a sophisticated zero-day. Rather, the third party is the weakest link. You know, especially when you see things like end-of-life technologies, insecure configurations, or other legacy unpatched systems. So Security Scorecard started 13 years ago as a security ratings tool, a way of being able to quantify and measure cybersecurity risk. Since then, we've evolved from the A to F score to looking at supply chain. So the supply chain, in the headlines now, 70% of breaches are coming from third parties. They're not coming from a breach on your own organization. So it's important to note that these bad guys are going to come through something that's left open as an open door. So this is outside-in assessment of what the Indo-PACOM region looks like, and then also a drill down into the Hawaii attack surface. So these are avenues into networks that are either third-party technologies, supplier technologies, and they're going to pivot into your organization if your supplier is the weakest link. So take, for example, the Sales Loft breach. They were able to access a OAuth key belonging to Salesforce and swim downstream to all of these different tenants. So they didn't have to compromise each and every organization. They just had to compromise one third party and then swim downstream and extract that information. Now when we look at it from a vulnerabilities, so internet facing is one aspect, what you see from outside in. Those are the technologies like this device here connected to the internet, your laptops, your servers, your IT technology. Then there's the devices that have a listed vulnerability, either it be a known CVE, which is exploitable by a bad guy, not necessarily a zero-day, but it could be known vulnerabilities, other kinds of vulnerabilities that may lay dormant that would allow remote code execution. So I'm a bad guy. I want to exploit some device here across this region here. I'm able to use popular scanning tools like Nmap, Nessus. I can find your attack surface. So we're essentially illuminating the attack surface of organizations around the world. So we see here that there's a ever-increasing and rapidly expanding attack surface, meaning more and more internet-facing devices are being connected to the internet. Surprisingly, some of these devices control critical infrastructure of the world: oil, gas, electricity, and other things like that. In the next example, it's going to talk about more of what actually is exposed from that aspect. So from a critical infrastructure perspective, these are devices that control water and waste utility systems, oil and gas. They are known as industrial control systems, or SCADA PLC devices, programmable logic controllers, It's physical hardware that is connected to a variety of different technologies, energy, gas, even water and waste treatment plants also utilize ICS SCADA type devices. So this map here is a geographical distribution of all of the critical infrastructure in the last 24 hours that's observed across the Indo-Pacific region. So this is either one of the popular brands. So the popular brands are like Siemens, Allen Bradley, Rockwell. These are devices. They're not that big. They're small little devices that are connected to the internet, unfortunately. And many of the examples of these devices, they have web servers. These web servers often have default credentials, so there's absolutely no credentials, or the pages are configured to allow someone to access the sensitive areas without authentication. That's very concerning, especially if you are doing business or you have relationships with a third party and these devices are connected to the internet. So we have a little map here as well for Hawaii, and then we have a larger map here for the Indo-Pacific region. So these are connected to a wide variety of different tech. So what actually are these devices? These devices here are internet exposed ICS devices. Many of them are end of life. So these don't have security patches. They do not have the ability to update their firmware. And unfortunately, they are connected to things like clean energy systems, waste and water treatment facilities, and they can't update them. So if a bad guy is looking to compromise a third party, they're going to go through that avenue, the low-hanging fruit. So we have here this technologies of Schneider Electric, Siemens, and other ones. We have some examples of these Siemens devices that basically allow bad guys to get to the custom application that controls the water and waste utility systems. We also see a number of other ones here that are end of life. And again, this previous slide here that showed that geographical mapping of those assets across Indo-Pacific region are these devices here. These devices run web servers. These devices here, if not properly configured, bad guys can get it. The same thing goes for any kind of third party. If their security hygiene or their security posture isn't good, it's more often that the inside internal network hygiene is not that great as well. And that's where most companies' data gets stolen through third-party breaches. It's not a 0 day on your front door. It's not even a 0 day on your third party. It's more of a exploiting the weakest path. And so what can we see with these devices that are on the internet here? So we see Siemens ET200SP. So this device here allows a full bypass. So that means I can access this device here over the internet. I can also see the complete network map. I can also stop this device. So if this device here is connected to critical infrastructure like oil or gas facilities, they technically could disrupt that and don't have to do any 0 days. They don't have to exploit anything in particular. They just have to go and find an operator who left one of these devices exposed to the internet when they set it up 5 years ago and didn't bother to lock down the web server. So this is, again, has the ability to log in, but unfortunately all the pages are exposed. And I can see full details of the electrical systems that it's connected to. Some other examples here that are rather concerning. This is a real live example. So this is here of what you could actually access. If I was a hacker and I wanted to access a water treatment system, this is an example where in the user pages, it's a custom area on the PLC controller where an application for that device is exposed. So here, no authentication. I can log in, I can turn off this pump, I can change its values. I can do pretty much anything here, and I have not yet exploited a 0 day, nor have I done any sort of sophisticated attack. So at minimal, I was just basically looking for what is exposed on the internet. So that's really one of the important reasons of having continuous monitoring. So having a view into your suppliers, having a view into the technology that is connected. These are grim examples here of what bad guys can do. So this is a sodium hypochlorite generator, which is usually typical in waste and water treatment facilities to scrub the water, essentially sanitize it. I can manipulate that and do some bad things. There's another example of where city dams are connected to the internet. So this is another example here of the same kind of PLC controller, end-of-life technology, the firmware is not being updated. Unfortunately, I can get right into the user page and see all the statistics about this dam. I figured out through simple information off this page where this dam is. So from an adversarial perspective, if they are looking for not only cyber attack probability, but also connecting it with kinetic attacks, this is another example of where I can get targeting information directly from devices that are connected to the internet. I don't need any special tools. And so when we look at why is continuous monitoring critical? So as we see here, there's thousands of ICS SCADA PLCs that continue to remain connected to the internet. You know, controlling water, energy, and manufacturing systems. We also see a lot of legacy and unsupported devices. So we see things like not only just physical technology related to IoT or ICS, we see a lot of outdated, unpatched technologies in general. So things like web servers, things where the IT guy basically turned on a server, left it in the closet, forgot about it, but it's completely exposed to the internet, hasn't been patched or updated, or it's running an end-of-life type of product that no longer has any support for it. Another good example of where adversaries are leveraging end-of-life technology is in the case of Volt Typhoon and Salt Typhoon. They're taking advantage of SOHO routers and other end-of-life networking gear in order to establish operational relay boxes. So that's a case where thousands of routers around the world, IP cameras, you know, things that you wouldn't think would have an implant on it, is being exploited because it's out of date. Or the technology manufacturer doesn't have a good updating or patching policy for those products, and those products basically expire on the internet and have no security updates for it. And the biggest issue here is the visibility gap. So the visibility gap is an understanding of who you're doing business with or who your actual suppliers are and what their security hygiene is. And so having an awareness of external reachable assets that these suppliers have is a good starting point. Without that, you can't protect what you can't see. So if I have 1,000 suppliers and they range from waste and water utilities all the way to clothing providers, you know, what kind of data is being shared with them, or what kind of access do they have to your environment? If you don't understand the full visibility of what they have from an outside in, if their hygiene is dirty, then more often than not, they have a higher chance of being breached. Also, in the case of attack surface, the dynamics are always changing. So continuous monitoring is enabling early detection of configuration drifts. Many of these devices don't just live for an hour, you know, live for a day. You have to have a continuous assessment because technology changes, servers are placed on the internet on a daily basis. You have to have that visibility continuously to understand what security issues, you know, ranging from out-of-life technology to vulnerable assets to exploitable vulnerabilities, and then also resilience. So the idea here is transforming security from reactive. Okay, I'm reacting to an incident, great. I'm already breached, it's game over, to a proactive approach, understanding your third parties, understanding the highest risk third parties, and then reaching out to those vendors and suppliers to improve their security hygiene. So what I'm going to talk about here, which is the principle of this presentation, is SCDR, supply chain detection and response. Basically, it takes the concept of XDR as well as CDR, but brings it to the supply chain. So we have what we call the supplier visibility. So having a holistic and contextual view of configuration risk, shadow IT, and attack surface vulnerabilities. Those previous slides are very good examples of having a visibility into your supplier's attack surface, changes in that environment, and even to the case of shadow IT. You know, many devices go up that may not be accounted for. You know, I'm pretty surprised that these ICS SCADA controllers are accessible from the internet, which shouldn't be the case. And then also being able to do incident response. So prioritizing activation of supply chain risk insights through SOC automation capabilities. So being able to work with the vendor, reach out to the vendor, provide that information necessary to improve their cybersecurity hygiene. And then also, the last but not least is supplier remediation. So asset management capabilities and issue resolution workflows. So it's one thing to detect it, it's another thing to respond and improve that security posture of an organization that you do not have any control over. So the idea here is creating an ecosystem of end-to-end clearinghouse to be able to respond and interact with your vendors to help improve with actionable and remediation advice to help improve that. So good example is that tool shell, where there's a SharePoint on premise. You know, the first question we always get asked is, what vendors of mine have a vulnerable version of SharePoint? That's the first question, because they want to know, is my information with that supplier now going to be exploited? Same thing with the MoveIt example. It's a common file sharing platform that's in the cloud. Unfortunately, the ransomware group, Clop, was able to compromise a number of organizations through a vulnerability and get access to third-party information. So the questions are, where is my data stored? Who are my suppliers, and what are their security hygiene? So that's all I have for you guys today. I think I do have time for questions here. Anybody has any questions here about the content today? Or I'll be walking around the hall here. We don't have a booth here, but it's our first introduction here to TechNet. Sure, yeah.
You mentioned, so you presented a end-of-life and vulnerable systems. Beyond the security scorecard solution, I mean, what my immediate thought is securing these assets, replacing the life things. What's the barrier to making that happen?
Yeah, so that's a very good question, and that's where working with those vendors to help them understand the security risk, because many don't realize that these devices are still there. So someone may have set up a test environment that's connected to the LAN, this device is end of life. Or if they're not aware of the patching cycles, that's where it gets into improving security, not just exposing what they are, but improving security hygiene for the vendor ecosystem. So that solution, we have a managed solution that basically helps organizations to operationalize this and work with those vendors to pinpoint those assets and either take them offline, update them, or do something different. Yeah.
Can you share what kind of military applications have been engaged in this in terms of customers or anything like that?
Yeah, so we have a number of military customers, governments around the world. One of the prime use cases is monitoring critical infrastructure. So a number of different government agencies have the mandate for, like a good example is in Canada. So they have a mandate to monitor critical infrastructure for the country. You know, without having an understanding of what the attack surfaces of those organizations are, it's pretty hard to monitor and improve security. TSA is also using it for a similar thing as monitoring airports, monitoring ports and entry for critical vulnerabilities. And the same would go for DoD, monitoring facility or suppliers that support the base. So like waste and water utilities, there was a case a number of years ago where Chinese hackers are hacking waste and water utilities nearby military bases. So being able to have visibility and monitoring those third parties that support the base or support the military operations is also key as well. Yeah.
If we want to get rid of the red supply chain, do we have to do the inspection on our contractor to examine their subcontractors to find out if any component coming from the adversaries?
Yeah, it's a good question. This is an automated tool that discovers not only the first party, third parties, and fourth parties. So what vendor is connected to the other vendor through a number of sources like contracts and other kind of relationships. So we're not just looking at like what you can see from outside in. We're also ingesting data that would infer, okay, this vendor here has actually got a contract with a technology company that's using parts from China. That's one way that we detect for automated vendor detection, which is another capability of this, is discover what your third parties are. That's the first step. And then the other step is figure out what your supply chain security is. What is the fourth party, fifth party, sixth party, and what is the blast radius? So that's what essentially the tool does. And another way of assessing is through questionnaires. So a questionnaire is a way of sending a RFI or request for information about your security posture. Often, many of these companies lie. So we have AI automation through a acquisition we did called HyperComply, which basically allows to match the security findings of the organization with reality and say that, okay, well, these answers here, it doesn't match with what we see from our data collections, which is 4 terabytes a day. So matching outside in, other different configuration controls with that of the questions being answered also helps to solve that problem as well. Well, all right, guys. Well, if there is no further questions, I'll give you guys like 6 minutes back. I know it's the end of the day. You guys all probably want to head to dinner. Thank you.